In today's video, we're going to be looking at distance. So our key concept is a distance formula on a number line. So if P has coordinates x1 and Q has coordinates x2, then PQ equals the absolute value of x2 minus x1 or the absolute value of x1 minus x2. So let's take a look at our first example. So in our first example, we want to use the number line to find CF. So I'm going to start off with listing what is the coordinate of C and what is the coordinate of F. So C equals -1. F equals 5. So using this idea that we have, CF equals the absolute value of x2 minus x1. So x2 is going to be my 5, x1 is going to be my 1. So this equals 5 minus -1. Well, minus negative turns into a positive, so this equals the absolute value of 5 plus 1, which is the absolute value of 6. So this is just going to be 6. Let's take a look at example 2. We want to determine whether line segment CB and line segment DF are congruent. So from previous lesson, line segment CB and line segment DF, we want to see if these two are going to be congruent. And that sign would be this, the equals with a little mark over it. So this is what we're trying to find. Remember what congruence means. It means that this line segment CB is the same as the line segment DF. They equal each other. So we want to see if these two equal each other. So what I'm going to do is I'm going to find the distance of CB. So let's start off with CB. So C is right there at -1. B is at -3. Then I'm going to do DF. D is right there at 2. F is right there at 5. So let's start off with CB. So with CB, I'm going to do x2 minus x1. So that's going to give me -3 minus -1. This double negative here turns into a positive, so this gives you -3 plus 1, which is -2. Remember what absolute value means. Absolute value means how far away from 0 this number is, and it's 2 spaces away. So this distance would be 2. Now let's come over here and solve for this one. So we're going to again use x2 minus x1. So my x2 is 5, so that's going to be 5 minus 2, which is 3, and 3 is 3 away. Well, 2 is not the same thing as 3, so CB does not equal DF. So these two are not congruent. And that's what we had to solve for. Let's take a look at example 3. But before we come to example 3, we have a key concept, the distance formula on the coordinate plane. If P has coordinates x1, y1, and Q has coordinates x2, y2, then PQ equals the square root. That's what this symbol right here means, the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to get out a number when we do that, just one number. So let's go ahead and take a look at example 3. So J and k. So we want to label our x1, y1, x2, y2. And the way I label it is the first letter that shows up, that's going to be my x1 and my y1. The second letter that shows up is going to be my x2, y2. As we saw in the first example, because we're finding the difference of these, it's not going to really matter. This can be my x1 and my y1. This can be my x2 and my y2. What matters is if this is my 1, this has to be my 1. I can't say this is my 1 and then this is my 1. I can't mix the two of them. I have to take from the same letter. So the distance formula, so jk equals the square root x2 minus x1 squared plus y2 minus y1 squared. So plug in the numbers that we have. So this is going to give me the square root of, well, x2, that's negative 3. So it's going to be negative 3. x1 is 4, minus 4 squared, plus y2 is negative 7, negative 7. y1 is 3, minus 3 squared. So simplify what's inside the parentheses. Negative 3 minus 4 more is negative 7 squared. Negative 7 minus 3 more is negative 10 squared. So I'm running out of space, so I'm going to go ahead and bring this over here. So this gives me the square root of negative 7 squared means negative 7 times negative 7, which is 49. And here I have negative 10 times negative 10, which is 100. Add those two together. That gives me the square root of 149, which is about 12.2. So again, the big thing here was you have to start off with labeling what's your x2, what's your x1, what's your y2, what's your y1. Once you start labeling those, you just plug them into the formula and then work it out. Let's take a look at example 4. So we want to find the distance between these two students. So we're going to start with graphing it, and I gave you the graph to begin with. So we're going to use the points C and A. So we're going to start figuring out who's going to be my x2 and who's going to be my x1. So I'm going to make C my x1, y1. I'm going to make A my x2, y2. So what does that mean? 212.0, that's my x1. 151.6 is my y1. And then my x2, that's going to be 435.3. It's my x2. And then my y2 is 311.3. It's my y2. So our distance formula, x2 minus x1 squared plus y2 minus y1 squared. Start plugging in our information. Our x2 is 435.3 minus our x1 is 212 squared plus our y2 is 311.3 minus our y1, which is 151.6 squared. So simplify what's inside the parentheses. So 435.3 minus 212 gives you 232 or 223.3 squared plus 311.3 minus 151.6 gives you 159. 0.7 squared. Now let's square these out. So when I square them out, I'm going to get some really big numbers. So that gives me 49,862.89 plus 25,504.09. Add these two up. That gives me 75,366.98. And when I take the square root of that, I get about 274.5. So they are 274.5 feet apart. And so the two ideas that we were working with were distance. So we were using the absolute value to find the distance. And then we went into 2 dimensions and we were using the square root to find the distance in 2 dimensions. Go ahead and write a summary for today.